start on 14 first, and then we'll dive into 15.
Yeah, sounds good for me.
Alrighty, let me pull it up real quick.
Yeah. So I kind of started the quiz. I got to question 5. That's as far as I've got so far.
On the group quiz?
Yeah.
Okay, sweet. Well, yeah. So I'm not sure how you did it before with the other group, but we would just go over any questions we had. Usually we wouldn't, especially for these chapters. They've been pretty easy.
Yeah.
And then if no one had any questions, we'll just dive right into the quiz.
All right.
Seth, did you have any questions from chapter 14?
No, I didn't.
Yeah, it's pretty much the same thing. It's plug and chug.
Yeah.
So, okay, let's go ahead and get started on it.
All right.
Pretty much, at this point, it's just determining which one we use. Because it's all pretty... Okay. Oh, I don't have any spreadsheets up.
I don't either.
All right, I'll be doing that in just a bit. All right, answer the first 2 by yourself. Oh, there's 18 on this one. Okay. So what do you guys, for question 3, is that true?
Yeah, that's what I got. Because they all have to equal.
Okay. I think that answers my question on 22 on the other assignment then. Because that was like that same thing. Okay, which requirements need to be checked when performing in, let me see if I have this on my notes here. See if I got it right.
Yeah, so for number 4, I have data in each group are normally distributed, and the variances are equal in each group.
Yeah, that's correct.
So the sample means are all positive doesn't need to occur?
No, it doesn't.
Yeah, I didn't say anything like that.
I gotta pull that up.
Okay, check to see if each group is normally distributed. QQ plot for number 5, right? For number 5, did you guys construct a QQ plot?
Let me see.
Normally distributed.
Yeah, I do.
Okay.
Would it?
We assume the variance in each group is the same.
Yeah, we check the normally distributed in each group is a QQ plot. Yes.
Yep. Correct.
Okay. Okay, for number 6, I think the answer is the largest variance is less than 4 times the smallest variance.
We assume the variance in each group.
Because yeah, here in my requirements, I put in my note.
Yeah.
Yeah, because
I have less than or equal to 4 times the smallest variance. Then we will conclude the variance are equal.
Yeah.
Okay. Mm-hmm. Yep.
That's under 3.2.
An ANOVA hypothesis test is equivalent to conducting 2 independent t-tests. Oh wait, hold on, sorry. All right. The ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? Okay, let's think here. Is it 8? I don't know. Hold on. 1, 2, 1, 3, 1, 4.
1, 2. Isn't it just adding, so that's 6.
Yeah, that's what I have.
Let's see here.
Because you just keep the amount, so 1, 2, 1, 3, 2, 3, and then you just add 1, 4, 2, 4, and 3, 4. Those are the only 3 extra you add, right?
Yeah, so I have 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4.
Yeah.
Okay.
So answer 6.
Yep.
Okay, sweet. All right, time to bring up our spreadsheets.
Okay, I've got mine pulled up. Now I got to pull up the soccer one.
Yeah, mine's taking a while. There it goes.
I'm plugging it in into the ANOVA one.
All right,
Awesome.
sweet. You're ahead of the game, Seth.
Well, I don't feel that way.
So for variable 1, that's just the the footwear, right? We just fill in all that.
Yeah, I think so. I don't think for these ones it really matters which one is variable 1. I don't think,
Okay.
but I just assume that it's going to be in order unless it specifies otherwise.
Okay. Good to know.
So wait, do we plug in socks as well
Yeah,
for variable 6? Is that what you guys did?
yeah.
Okay.
Mhm. I haven't done it yet. I'm getting there though.
Okay.
We used this spreadsheet once before on a different. All right, did you guys all finish that up?
Yeah, I'm
Yeah.
wrapping it up, but yeah.
Okay. Well, I came out, just to make sure we all have it correct, I came out to an F score of 2.02.
2.02. Yep.
Okay, sweet. All right. Let's see what the question says. Each row represents a What is the minimum smallest variance for the 6 groups? What is the smallest variance? Okay. Does it give us that calculation? There it is.
What is the minimum? Is it 27.208?
That's what I got.
Same here.
27.208. Wow, that was an easy question.
And then 53.158.
For the maximum, 53.158. Let me check. Check that. 53.158. Yep, that's what I got. the test for the equal variances is satisfied for these data. Yes, true.
Yeah.
Wait, and how do you guys? Where are you guys getting that?
For number 10,
Yeah.
so number 9 is not 4 times bigger than number 8. So that's
Okay.
all it's asking.
Okay.
Right. Okay, so now we got to do a QQ plot for all of them. Bring out another spreadsheet. So on this one, I think the spreadsheet is the quantitative description. Yeah.
Yep, QQ plots.
So now we just copy and paste each one of them individually and then set it in order from smallest to largest, correct?
I think so.
Okay, that sounds like fun.
My Excel's being really slow right now.
Yeah, I really think I did this one already, and I'm pretty sure they all are normal, but I'm gonna do it again. Just in case. Seth, do you know where we're at right now?
Yeah. Oh well, on number.
Oh,
So A is normal. A is normal.
I'm trying to get the QQ plot.
Let's see what B is.
Well, I didn't.
Dude, the hardest part about this class is having the patience to go back and forth between pages.
man. Yeah. And I'm not very advanced with Excel, so I'm learning a lot just with how to work that too. So
Yeah, same. It's been helpful to learn all that for sure. Okay,
yeah.
I think B is
Wait.
normal as well. Do you guys do B yet?
I'm still doing it.
Okay.
Yeah. Wait, where are you grabbing the QQ plot? Which
Quantitative description. I'm not sure which lesson it is, but I just have it from another.
Let me see here. Maybe I can send this.
It's quantitative descriptive statistics or
Yeah,
Yep.
statistics.
descriptive.
Okay.
Yeah, the descriptive one, not the inference one.
Okay. I have the other one pulled up.
I actually want to take them all and see if I can put them onto one spreadsheet. I don't think it should be that hard.
I hope not.
Okay, I got normal for C as well.
Yeah, I did too. I'm still punching in. I have a feeling they all are going to be.
I'm pretty sure they are. All right, D is normal.
And how do you sort from highest to lowest again?
Just in the top left or top right corner, it says sort
Okay.
and filter. Smallest to largest. Okay, I got normal for E.
I think they're all going to be normal.
I think you're right.
Is F considered normal?
F, I don't have an F. Hey, what are you talking about?
For variable 6? I'm sorry.
Variable 6? You mean socks?
Socks.
Yeah. It has like
Yeah.
that. Okay.
That one right at the beginning, yeah, that'd be normal. I'm gonna say they're all normal. You trust us, Seth?
Yeah.
Okay.
'Cause
they're
I
normal.
pulled up. I just did 4 and 5 and 6, and so
Yeah.
just 6 looks a little.
Yeah. It was a little. It looks a little funky, but I think you would consider that normal. Okay. Perform an ANOVA test in SPSS or Excel and observe what the p-value is. Observe that the p-value is 0.081. Then remove the SOX data and test again. What is the p-value when we remove SOX? Okay. So they said it's 0.081.
Yeah, currently. Yeah, that's what I have.
Okay, so now remove variable 6.
0.309.
Yep. Alrighty. Everyone good at as long as all the way up to number 12?
Yep.
Yep.
Number 13. The test statistic for ANOVA hypothesis is an F statistic. Is the p-value of the area the area to the right of the F statistic, right or left?
Okay, let's see. So in the F statistic, in the notes it says the p-value is in the area in the right tail. We'll never decide.
Yeah.
Yeah.
It's only the right tail. Yeah. I remember that.
And then, okay. So let's see.
Okay. Oh, yay, another spreadsheet. Okay, hot dog nutrition.
Hot dogs. Yuck.
B. Okay. So there's 3: beef, meat, and poultry. What is meat? It's kind of okay. Let me bring up that new spreadsheet for quantitative inferences.
Mine's still loading the hot dogs. It's being slow.
No worries. I'm bringing some new stuff up too. ANOVA. Researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat. What's meat? What? So meat, could that be anything? That's weird. Anyway, mostly pork and beef, but up to 15% poultry meat. Okay. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available in the file hot dog nutrition. Use this data file to answer the remaining questions. Okay. Let's examine the calories first. Construct a QQ plot of the calories for each of the 3 hot dogs and compare the variances to determine if the assumptions of the ANOVA have been met. Okay, so now we're going to do a QQ plot for, what was it, the calories?
Calories.
Yeah, so, calories. Okay.
Let's see.
Some more plug and chug. Calories of beef.
So for beef, what did you guys get? Does it look like
Hold on 1 second.
Okay.
I haven't done it yet. I'm moving too fast with the stuff. Okay. So calories. You said calories for beef?
Yes.
Okay, hold on.
Yeah, I would say that's normal.
I put in the whole spreadsheet. I got to redo it.
For beef calories, I would say normal stuff.
Okay.
Close enough. Because it's following the line for the most part. What he's really looking for is when it's like extremely wavy.
Okay. Then how about for the next one? I guess it's kind of aligned, but for
I haven't
me,
done that one yet. He wants that. And this one's for the meat calories, right?
yeah. Yeah, it's normal, even though it's kind of wavy.
Oh yeah, I don't know.
I don't know how we classify. I mean, I get when it's normal and when it's not, but it's a lot of gray.
Yeah, it's gray area. Oh, let's see what the last one is. Hopefully the last one's like way off, so we know what to answer there.
It's similar to the next one.
Gosh dang it. Well, luckily we get 2 attempts.
See that.
That's good.
So we're gonna classify them as normal.
I think so. Sorry, let me do one. I haven't checked. I didn't look at the last one yet.
Yeah.
So here's what I'm thinking. I think we say that they're not normal because, I mean, we just did one that was normal.
Yeah. It does look off. Like.
So, yeah, it looks a little bit odd. So then what's the second? So we'll say that it's not normal. And then what was the second part to this question? Compare the variances. Ah, dang it. I should have been copy and paste it to the other one at the same time.
Oh yeah, I didn't do that.
Okay, well, back to square one. And we're just doing calories again, right?
Yeah.
Beef calories.
So I have that done now for the variance.
All right, give me a sec. Oh crap! Sorry guys, you're gonna have to bear with me. I accidentally just deleted a bunch of stuff.
Oh, it's okay.
Happens.
So how do we consider the variances equal?
Whether or not it's 4 times as large.
Yeah. Okay, so I guess all of them are equal because they're not 4 times as large.
I think so.
I'm just looking at the notes and see it, but I feel like that's right.
Or maybe, yeah, I'm pretty sure that's the case.
Okay, so the rule for variances is if the largest variance is less than or equal to 4 times the smallest variance.
Okay.
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 Then we're
Yeah,
good on.
we'll say they're equal. Hey,
Yep.
did you guys get it? So when you guys input it, just to make sure I have it correct, did you guys get a F score of 16.74?
Yes, for the F.
Yeah. Okay. Cool.
Yeah.
Okay. So going back to the test here. Okay, the assumption have been met, or the assumption have not been met. Wow, it's safe to assume. It's not met.
isn't it C? The assumption have not been met. It is not safe to assume each group comes from a normally distributed population, but we can assume that the variances are equal.
That's what I'm thinking. Yeah, so it's either going to be that one or it's going to be the top one.
Yeah.
So we will find out soon enough. Okay, so we're going to go with C.
Yep, that's what
Okay.
I know.
Okay, number 15. Run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find the degrees of freedom are 2 and 51. Okay. P.00 with a level of significance. What conclusion do you draw? Okay, so we don't even need to go back to it. So the mean number of calories are the same. Hold on, well, what was the, we have to go back to the test. What was the test that they're trying to determine? So researchers for each, you wanted to analyze and recorded the calories and sodium level. The data above uses data file to. So I think since we have a level of significance of 0.05 and p-value is 0.0000, so we're smaller, so we're going to reject the null that they, hold on. So I think we previously assumed that they're all the same. Researchers recorded. So I think since we're rejecting the null, we have sufficient evidence to claim that they have different mean number of calories. I think it's C.
C, yeah.
So what do you guys think?
I'm still doing the math to means, but I mean they're
that one's a little tricky.
Because it says you should find that the degree of freedom are 2 and 51.
Yeah.
Well, F equals. So does that mean there's going to be a difference from variable 1 to variable 2 of 2, and then from 2 to 3, 51?
No, that's not what it's saying. What that's saying, that's just trying to let us make sure, say, hey, when you punch all the data in, this is what you should be getting. It's not.
Okay.
That information is not necessarily important.
Oh, okay.
But I think since we're lower, we're rejecting the null. The null was previously that they're all the same. But since we have a p-value that's really small, I think we reject the null, which means that they all have they have different calorie types or calorie amounts.
Makes sense.
Okay, sweet. Now let's examine this sodium levels. Oh, come on. Okay. All right, construct QQ plots for the sodium levels. Great. Alrighty, well, let's start from the top again. Sodium levels of beef.
I guess normal.
Okay, let's see.
It seems less normal than the last one.
Yeah.
The other one seemed more normal.
Oh boy. Oh, let's just keep going through and see what we if we hopefully we can get one that's way out there.
That one's pretty close. I would say that's normal though.
Sorry.
That one seems off. The last one.
Okay, let me double. I'm getting to it. Can you click that?
So I think we might want to change the first one to normal if this one's way off. I don't know.
see here.
Yeah, that one's not normal. But
Do
the
you
first
think
one,
the previous one?
I still think the previous one was not normal as well because it kind of looked like that.
Yeah.
Okay, and now let's punch it into the other one. I'm sure now we got to do that. So we can
For the
get the variance.
exam, for the exam, we only have one shot, so.
I know. So we'll find. I guess we'll find out the appetite here. Okay. So sodium for B.
Let me know if you got F as 1.778.
All right. F.1 or F is 1.778. That's what I get.
Yep.
Okay. The variances are equal from what I'm looking at.
I'm looking at I think it might be C, because we're agreeing that it's not looking pretty normal.
Yeah.
But I think the variances are equal. I think C for that one.
Yeah.
Yeah, it's
Kind of
the
the
same
same
as
answer
last
as the
one.
last one. Yeah. So I agree. C. Okay. Despite the possible problem with the QQ plot for poultry, you decide to use the ANOVA to determine if the sodium levels are the same for all three groups. What is your p-value for the test? P-value is
0.179.
179. Okay, so what is your conclusion? So we have.
Sufficient evidence.
So this one would be insufficient, I thought. Oh my gosh. Okay. Because usually when we fail to reject, it's insufficient evidence. That's weird. That's not an option. Great. Okay.
So at the top one, we have sufficient evidence to claim that all three hot dog types have the same mean sodium levels.
Oh, I think so.
Because the p-value is greater than the alpha.
Yeah, I'm pretty sure that's correct. So I'm just reading through them to make sure I'm not like getting confused here, or just because they're worded very odd. Because usually it should be we have insufficient evidence that they're different. That's usually how it's worded. I think you're right. I think we should. What do you think, Garrett?
I think it looks good. I actually hold on. I just submitted it just to try it. We got 80% so far, so that's good. Let me just look here. The first one we have wrong is number 7. No, number 8.
Okay.
Number 8's the first one. So we got number 8, number 14, 15, 18.
So what answer did you have for number 8?
So for number 8, let me see.
Yeah, I
Here.
made it.
I had 2.02.
Oh, it's
Oh.
27.208.
Yeah, that's what I have too.
Oh, what did I put then? Well, okay. So that one was fine. What would I say? So 14,
So
I
14.
had, so it's not C.
So 14 for number 14. What was the answer? Can you read it?
I wrote, or the one I put was, the assumptions have not been met. It is not safe to assume each group comes from a normally distributed population, but we can assume that the variances are equal.
So I guess it is normal.
I guess so. So it's going to be A. So it's going to be. So do you think that's correct, Seth? So we would put
Yeah.
A. Okay.
Come here and talk to me.
All right. And then
I'll be right back, guys.
15. So 15, I have, we have sufficient evidence to claim that all 3 hot dog types have a different mean number of calories. That one's incorrect.
Really? Oh man.
Well,
Okay. So you said we have sufficient evidence to claim that all 3 hot dog types have a mean difference.
Have a different mean number of calories.
I think it's D.
Let's see here. I wish it would tell me.
Yeah, because I originally, if I saw D, I think I would have chose that one because it's not necessarily that they're all different. It's just that one of them is different. Do
okay.
you agree? So 15, we're gonna put D.
Okay.
Okay. And what was the other one you got wrong?
So 16's good, 17's good, and then 18. For 18, we have sufficient evidence to claim that all 3 hot dog types have the same mean sodium levels.
Oh my gosh, this is tough. All right.
Because that.
So is it the last one then? We have sufficient evidence to claim that at least one of the hot dog types has a different mean. So it's just one of them.
I don't think so because we're higher than the level of significance.
Oh.
Would it be the second one? We do not have sufficient evidence to reject the claim that all 3 hot dogs have the same mean. So we're saying we don't have enough evidence to say that it's not all the same.
You're right. You're correct. It's a double negative. That is worded so horribly. Okay, I'm gonna go ahead and submit it like that. I think we have it right now.
Okay.
Can you guys hear me?
Yeah.
Yes. Yeah, that's correct. We got 100.
Okay. I'll open it back up.
I'll walk you through it.
Okay, 1 second.
Okay, and Michaela, we're on lesson 14 group quiz.
You just finished that one?
Yes.
Okay.
Yeah.
So we're still going over it because we're just checking them.
Okay.
For Garrett.
Okay. It's loading right now. All right. So number 3
is true.
Okay.
Number 4 is data in each group are normally distributed and variances are equal in each group.
Okay.
5 is the construct a QQ plot for each group.
Okay.
6 is the largest variance is less than 4 times the smallest variance.
All right.
And that was B, I guess. Number 7 is 6.
Okay.
8 is 27.208.
Okay.
Number 9 is 53.158.
Okay.
Number 10 is true.
Okay.
11 is true.
Okay.
Number 12 is 0.309.
Do we skip 9?
What?
Did we skip 9?
No, we're on 13.
Okay.
Then question 13 is right.
Okay.
14 is the top one. The assumptions have been met. It's safe to assume each group comes from a normally distributed population from the QQ plots, and we can also assume that the variances are equal.
Okay.
15 is the last one, D. We have sufficient evidence to claim that at least one of the hot dog types have a different mean number of calories than another type.
Okay. Perfect.
16 is C. The assumptions have not been met. It is not safe to assume each group comes from a normally distributed population, but we can assume that the variances are equal.
All right.
17 is 0.179.
All right.
18 is B. We do not have sufficient evidence to reject the claim that all 3 hot dog types have the same mean sodium levels.
Perfect. Okay. I'm submitting it right now.
Alrighty.
Awesome. 100%. That's what we like.
Hey, good job, guys. So, Garrett, how far along did you get in lesson 14 or lesson 15?
I honestly, I have not started it yet, but I'm more than ready to go ahead and get started with it. So,
Okay, cool.
yeah.
So let's go ahead and do that. And I have the answers that I have. So hopefully that, let's see, there's a couple that I had questions on.
Okay.
We can, I mean, we'll go through those eventually. But,
yeah, and that's the same with me too. There's just a couple that I think I know, but some it's up in the air.
Okay, cool. How did you do on the homework assignment? She's still there? Oh yeah, you are. How'd you do, Michaela?
I didn't do the question. You didn't say my name, so.
Oh, sorry. Yeah. How did you do on the assignment? Did you have any
Chapter
questions?
15.
Yeah.
I haven't even looked at it. I mean, I looked at it and I started reviewing it, but I hadn't do the questions because I wanted to go back and review last week's lesson because I didn't get a chance to go back and review that.
All right.
Like watch the videos or anything because I just really struggled last week. So I wanted to go back and do that before I did that. So.
All right. Well, let's go ahead.
Since 2 of us haven't done it, you guys want to meet a different day this week?
I think we can just go through it. I don't have open days. I'm pretty busy.
I'm all right to go.
Monday's my staff
I don't want it to feel like, I just don't. No, I don't know. I don't feel like I haven't done the work because I want to do the work. Does that make sense?
Yeah. Well, we'll go through it. We'll go through it.
But
right now, we'll all just go through it together and make sure that we're all doing it right. So.
Yeah, and that we're all on the same page with it, and we all understand every question.
So. Alrighty.
Sounds fair.
Okay, I'm going to go ahead and start it. Lesson 15 group meeting.
Oh, you're just starting the meeting on the chat, not the actual quiz?
No,
or do you want to start the quiz?
Yeah, we're starting the quiz.
Okay, okay.
Okay. So many Excel files.
See, I completed this assignment in my office at work, and I have 2 screens, and it makes it so much easier when you have 2 screens.
Yeah, I agree.
It's unbelievable. Okay. So there's 26 questions, right? Just like the assignment? Oh, there's 32. Oh, it probably just breaks it up.
Yeah, 26 is how many questions there were.
Okay. Let me pull it up. Because it's not going to ask A, B, C, D like the homework does. It's probably going to give ask for the actual ones. So I'm going to pull up. I need to pull up the what's it called? The actual textbook look like?
Most of them are ABCD.
Oh, are they?
Yeah, there's a couple where we type in the answer, but most of them are ABCD.
Yeah.
Okay. Yeah, I'm gonna pull up the textbook because on the textbook they were all ABCD and with some numbers as the answers, but they're ABCD. And I just wrote down the letters. I didn't write down the numbers, so just give me a second. I'll pull up the textbook. Okay, here we go. Okay, so go to the quiz. Answer the first two questions by ourselves, it looks like.
Well, the first one.
Okay. Oh, just the first one. Okay. So
Number 2, it says, given a 90% confidence interval of 45, 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? I got we are 90% confident that the true mean heart rate is between 45 and 105.
is that A in the textbook, do you know?
Yes.
I got
Yeah.
it.
So.
Okay. Yeah, I think I got the same.
Wait,
So it's
so I
we are
got
90%.
so you said we are confident of that the true mean rate lies between 45.
No,
Is that what you
Yes.
said?
Yes, because
I
we're getting the
believe
confidence
90% of
level.
all heart rates are between 45 and 150.
no, yeah, that one. It's we are 90% confident.
We are.
Because
Okay.
we're getting
Yeah.
the confidence level. So with confidence, you get the confident. We're it's the percentage of like we are 90% confident.
Okay. I got some of them done, like the first 2, but I didn't get any of the rest of them done.
So just to recap, the answer is it's B. We are 90% confident, correct?
Yes.
Yep, correct.
Okay. Alrighty, number 3.
The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they created QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? I got no. The distribution of the mean of each sample is not normal since the sample size is not large enough, since it's not above 30.
Agreed.
Hold on. Hold on, I think to determine whether the confidence interval would be.
Oh, wait.
Yeah, because they talk about the QQ plot, so I think it's C. That's one I got.
Oh, yeah.
Let me see.
So
There's
Or not
Go
C.
ahead. Well,
Or no, not C. So it's C on the textbook, but I think it's no, because the what is it?
So the distribution of the mean of each sample is not normal since the sample size is not large enough.
Hold on.
yeah, because I kind of think it's A just because it says. I mean, we're doing this from 2. There's only 2. How am I trying to say this? I don't know actually.
Well, actually, it might not be that because if you grab both 20 females and 15 males, that's past the 30 that's required. But I got number 2.
It would have to be. I think now that I'm looking at it, I'm just confusing myself because they have it in different order.
Yeah.
Oh, it's so
In the
annoying.
textbook, I got C, which is no the distribution of
So
the
I
mean.
got the same thing. Okay, I got the same thing you guys got. But on the test, it's A, right? No,
Yeah.
the distribution is not large enough.
Correct.
Okay. 4. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
I got in the textbook C, but for this one I got A, confidence intervals for the mean of difference using dependent samples.
Yep.
Is it dependent? Because
it's either dependent or independent, but I'm feeling that it's dependent.
well, because it's 20 females and 15 males. If they were dependent, they would be an equal number. Because if dependent would be female, it would be like husband wife, because they're not because there's no other connection other than just males and females. I think they're independent.
It would be independent because there's nothing that tells you what is in the other column, right? Is that what we're talking about?
Yeah. So if we're doing females to males and we chose the husbands of the females, we chose the husbands because it depended on what women we chose. But it's just males and females. There's nothing.
Okay.
Does that make sense? Do you guys agree?
Yeah,
I agree.
That's using independent samples.
Okay, sweet. That's what. All
Which
right.
is C.
Okay. Cool.
A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of the bank customers is found to be $3,402.08, $4,142.75. Which of the following would produce a confidence interval with a smaller margin of error that this 25% confident interval?
I think it's D in the test. Obtain the balances of 90 bank customers rather than 30.
Yep, I agree, because the larger the sample, the smaller your. Yeah, I agree with that.
So B, obtain the balance of 90 bank customers rather than 30?
Yeah, so on the test it's D, yeah.
Okay. Because I kind of got mixed up on that. I felt like it was B, but I thought it could also be D. If that makes sense.
Yeah. Well, because if you have a bigger confidence interval, the number gets bigger. So, all right. Information.
Well, because the reason why I thought it was none of the above, because since 30 is already normal, having more is just it's already a normal sample, so that was my thinking, but that makes sense.
Okay, sweet. Alrighty, number 6. Let's see here.
A factory makes color drives. Quantity assurance engineer at the factory needs to estimate the true mean length of the shaft. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution, whose standard deviation is 2 millimeters. Calculate 95% confidence interval for the true mean length of the shafts. Input your answer for the margin of error, low bound and upper bound.
Okay. So Seth, just to make sure we're on the same page, did you on the textbook, did you get A?
Yes.
Okay, cool. So Garrett and Michaela, you guys know how to do this, right?
Let me see.
Yeah,
here.
I just got stuff.
Yeah, I'm just putting it right now.
So the mean is 1,000. So, and then you have to calculate the 95% confidence interval. With the, where is it? With a standard deviation of 2 millimeters, which comes out to be 1.96. So 1,000 plus minus 1.96.
Okay, let's see here. So when you're typing that for an answer, it's
So first we just find the margin of error, and
okay.
for the first question, the answer is 1.96. Is that what you got?
Yep, that is what I got. Which is
Is that what you got for 6?
What?
For 6?
No, we're good.
For 6, that number 6 is not really in the textbook. It kind of is, but for number 6, we're just trying to find the 90, or we're determining the margin of error. We're not looking for the upper bound or lower bound. But the margin of error, did you get 1.96?
Yeah.
Yes.
Okay. So for lower bound, did you get 998.04?
Yes.
Okay.
And so, did you use the paired sample t-test?
Probably. I'm just no. For this one, no. This one, it's just the z-score formula.
You can use either one.
Yeah.
Right.
Okay.
I don't know, because on this one there's no
No,
there's
no
nothing,
number.
yeah,
Yeah.
there's nothing to compare. So you're just going off of one.
Oh. Okay.
I get that.
So
So, what
And-
formula did you use?
let me see here. So I'm pretty so we're working with z-scores right now because we know what we know the standard deviation. So it's confidence interval deviation known. I have the notes on my phone because I left my notes at work, but luckily I took a picture of them. So the formula that I'm using is, we have the test statistics, so we have z. So we know z is 1.96 because of the little table thing, and then sorry, it's in the other notes. The formula for margin of error is z times standard deviation over n squared, or the square root of n. So it would be 1.96 times 2 divided by the square root of 4. So you end up getting 1.96 for the margin of error. Then you take 1.96 plus and subtract it from
You did the square root of n?
yeah, which is 2. So then you have 2 divided by 2, which is 1. And 1 times 1.96 is 1.96. So you got a margin of error of 1.96, and then you take that number, you add it to the mean, and then you subtract it from the mean. That's how you get your upper and lower bound.
Yep,
Wait, so for the lower bound, I got 998.04.
Yeah, that's correct.
Okay, sorry. I thought someone said 0.6, and I was like,
It's 1.96 for the
yeah,
margin of error. Okay.
right.
Oh. So determining the margin of error is the 1.96, and then the lower bound is the 998.04.
Yep.
Correct.
And then for upper bound, I got 1001.96.
Yep, same here.
All right, cool. All right, question 9. different problem. I can't remember what I did for this one. Okay, 2 SS. I remember this one. So yeah, this is the formula to solve for n. It took me a while to find this one.
Did you get to solve for n? N equals, this is all in parentheses, z times the standard deviation over m, and then you square root that?
Correct. And Seth, in the textbook, did you get C?
Wait, what's that
No.
formula again?
It's number 6 in the textbook.
No. What was the formula? X times the
So
standard
it's-
deviation.
So it's n equals z times standard deviation divided by m as in Mary, and then you
Square that.
square that to the power of 2. The answer of that.
M as in Mary's in the marginal error. Is that what you're saying?
M as in Mary. What is m again?
Error.
I think
Margin
so.
of error.
Yeah, I'm pretty sure it is.
Okay.
And our z-score was 1.96 times the standard deviation, which is 2.
Over 0.0001. Right?
No.
I'm trying to remember what M stands for. I'm pretty sure M is margin of error, but I'm not sure. I thought I wrote it down.
I'm trying to go through the notes and see.
But the answer, Seth, for number 6 in the textbook, what answer did you get?
I probably typed it in wrong. I got D.
So I got, if I did it right, I got 196. Is that right?
That's not an answer. That's not one of the answers in the textbook. So
Okay.
you can kind of check your answers if you go through the textbook because it's A, B, C, or D. And so what I did.
So
Let me do it again. Make sure I'm doing it.
0.996, right?
So I took 1.96 times 2 equals.
Why are you timesing it by 2?
There's a standard deviation. Oh wait, no, I'm looking at a different problem.
I forgot to square it.
The standard deviation is that 0.01?
Yeah.
And oh, is it 0.01? My bad. Okay, 1.96 times 0.01 equals times. What is M? I'm trying to remember what M is. No,
Margin of error. So is that 0.0001?
Or that I thought 0.001 was the yeah, I guess so. Yeah, it is. But I thought we just determined that the margin of error was 0.96 was 1.96. Or that's a confidence interval.
Well, I thought that was the Z.
No, well, it says determine the margin of error of a confidence interval of 0.95. So I'm really lost right now because now it's like giving us an answer. Oh no, it says the confidence interval for mu. It's not. It's asking for mu now, so it's a little bit different. Okay. Divided by 0.0.
Okay, I got it. I got 38416.
Yeah, that's what I got. Okay, good. See in the textbook. That's what I.
So it's 1.96 times 0.01 over 0.0001, and then you square root that.
Yeah.
Okay. Number 10.
I wonder why they use the square root, or they use the margin of error of 0.00001. So I thought it was just above we answered this. The margin of error was was 1.96, but
It's a different thing. This is a different thing. It's a different.
Is it? Oh, is it a different problem? Okay.
Yeah, that's why.
Sorry, I didn't realize that. Okay.
The mean area mu of the several thousand apartments in the new development is versatized to be 1,250 square feet. Attended group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicions. The appropriate null and alternative hypothesis. And then, yeah.
Okay. I got
D.
the last one. Yeah.
Yep.
So we're testing.
So it should be mu equals 1250, and then for HA is mu is less than.
Yep.
The alligator should be even 1250.
Yep, I agree. Yep, B looks
Okay,
good to
cool.
me.
All right. In the statistical test hypothesis, we say we reject the null hypothesis with a level of significance if. So in a statistical hypothesis.
Less than? The P is less than, you'll reject the.
If p-value is less. If p-value is less than alpha, so it's the second one.
Yeah.
Correct.
Yeah, I finally did that.
Okay. Statistics students wants to determine if students in an apartment building get better grades than students in another apartment building. They collect GPAs from anonymous random sample of 15 students from each apartment building. The data for each apartment building is bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis to answer this question?
I got yes.
Yeah, it's definitely yes.
And then I got it's C. So it is enough that the data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal.
Isn't that always right askew?
Ooh, good point.
Yeah. And then don't you have more than just two? It's usually a 3 thing when you use normal.
Yeah, but is it?
You can use it for 2, but it's used for 3.
I know, but each, I think it's the total. The differences should be right skewed, but I think each individual data set has to be normal.
Okay.
Because in the last test we were just testing to make sure each of them were normal.
Okay.
Does that make sense, guys?
I just
remember
Nova is always right askew, so that's why.
Yeah, and I remember that too. But I think when we're talking about right skewed on the ANOVA, I think we're talking about the differences from the variables. Let me go through my notes again, because in the last test we had to determine to make sure each data set was normal on the QQ plot, or else we couldn't do it. Because okay, so that's characteristics of the F distribution. That's not necessarily of each data set.
Okay.
I think. So I'm going over the requirements. Yeah, so one of the requirements is the data are normally distributed for each group. Use a QQ plot of descriptive statistics to use with the data. So I think it's yes. The data is the one that is C. So the third from the top.
Okay.
Alrighty. Question number 13. I remember this one from the homework. I think it's a type 1 error, but let's go ahead and go through it.
Okay, that's what I got. A.
Okay. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival after diagnosis is the same for the new treatment and the standard treatment. In the early trial, she tries a new treatment on 3 subjects who have an average survival time of diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant and at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment is not increased. It does not increase the mean survival time of patients. Which type of error is this? So she rejects the null when she should not have rejected the null.
Yeah, so that's the first row, last part, or there's the first box, second box. It's in the second box, which is the type 1 error.
Yeah, that's what I got.
So
Okay.
if they had accepted fake data or data that wasn't sufficient, that would have been type 2.
Yeah, so if they
Yeah.
failed to reject they should have rejected, it would be a type 2. Correct. Okay, cool. All right, go to number 14. If the level of significance alpha is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? By reducing I think it's C. No, not C. It's A. By reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
Yeah, I agree with that.
If you remember, they're inversely connected.
Yeah, exactly.
Okay,
Yep.
cool. All right. The nicotine content in cigarettes of a certain brand is normally distributed with a mean in milligrams and a known standard deviation of 0.17. The brand advertises that the mean nicotine content is 1.5, but measurements on a random sample of 100 cigarettes gave this brand a sample mean of 1.53. Is this evidenced by that the mean of nicotine content is actually higher than advertised? To this test, or to answer this, use test the hypothesis. Okay. So for this one, you gotta find the p-value using the probability applet.
Okay.
So to start this one off, you gotta find the z-score. Okay.
No.
So the z-score is, the formula for that is x bar minus mu over standard deviation divided by square root of n. So it would be x bar would be 1.53, subtract 1.5 divided by 0.17 divided by the square root of 100.
Which is just 10, right?
Well, yeah, square root of 100 is 10. So essentially what it comes down to is you take 0.03 divided by 0.17 divided by 10. You should get 1.7 something, I think. I can't remember.
1.765.
Yeah, okay. And then you plug that into the normal probability applet, and you highlight everything above.
So I got 0.0388.
That's what I got originally. And we're using a level of significance of 0.05, so we're smaller. So we reject the null hypothesis. Does that make sense to everybody?
It does. I mean, it's a little tricky to follow. But
Okay, do you
yeah.
want to walk through it again?
Let me see. Because you start with the z-score, so I got that, and then you just kind of plug into the other one, right?
Yeah. So you plug it into the applet, and then you highlight all of the above.
Okay, I see. Perfect. Okay. Yep. Reject the null.
Sweet.
So that's D. For 15, you guys got D, correct?
Yes.
Correct.
For 16,
You would like to. Oh, go ahead.
I was just gonna ask if 16. I got B for 16.
Okay. Let's see here. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample for 100 each. Group test, different. What is the procedure? Yeah, it's independent.
Yep. I like that too.
Okay. Oops.
By males and females with similar academic support system. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only one brother-sister pair when they are next to each other in the sibling order. Should she use a hypothesis test based on independent or dependent sampling? It'd be dependent because you know which is going to be.
Yeah, so it's going to, from what I did in the homework, there's a couple of questions, so there's two versions of saying it. I got D from the test, which is, it's not the sister's academic achievements depends on some degree her brother's. It's, you pick the brother because you pick the sister.
Right.
Okay, so it's D.
Yep. Perfect.
Sorry. Move this down. Okay, so this one requires the spreadsheets. Okay.
I hate how it asks me if I want to enable editing. Crazy.
Hey, Seth.
It's the only you've been using, right?
Yes.
Hey, so this is number 15 on the textbook. Did you get B for 15?
No, I got D.
Okay.
But I was probably off.
Okay. Well, so let me pull this one up in this spreadsheet again, because I think the answer is B, because there's nothing to compare. We only have one set of data, I believe.
Okay, yes.
Are we going back up to 15? I thought we were on 18.
Oh, no.
Dissolved organic.
It's 15 in the textbook. So
Yeah.
that's what I'm talking about.
Dissolved organic carbon only has the one test, so yes. You can only do one sample test, and so if we are gonna
And standard deviation is not known, so we would do A.
Okay.
Okay. Number 19.
How do we know? So are we no longer using the first Excel thing that we've used anymore, or are we only doing the sample ones, pair sampling?
Well, it just depends. We could be either doing a z-score, we can be solving for T, we can be solving for F, or we can be solving for the pair. So
How do you know when to use which one?
Well, if they're independent, you use the two sample. If it's dependent, you use the paired. If there's more than one and it meets all the
But how do
requirements,
I know when to use what I was getting? Sorry to interrupt. I know, like I get those ones, but how do I know? Because you guys use the one sample, correct?
yeah.
So how do I know when to use that one versus the other older spreadsheet that we had? The one with like the graph and where it gives you the mean and the standard deviation, everything like that, and the Q1 and Q3.
Well, because we're working with confidence intervals. That one doesn't deal with confidence intervals.
Okay. Whenever it says confident interval, I don't use that one. Is that what you're saying?
Well, you could. It just, I mean, with this one, it's going to ask for confidence intervals and it's going to ask for margin of error and things like that. So it's not because the other one, all it gives us is it will graph it so we can know if it's normal, and then it will also give us the mean and standard deviation, and we don't need to know that stuff.
Okay.
Okay. So determine the margin of error for a 95% confidence interval. So I actually got to do this because it doesn't ask that question in the textbook. So just
Yeah. So is the standard error of the mean different from the margin of error?
I'm gonna look through the notes. Let me see here.
How I addict it from, I don't know, stupid thing.
Thomas, do you know if the standard error of the mean is different from the margin of error?
I don't know. I wouldn't trust that though. I would just subtract it. I don't think it. I think it's something completely different.
Okay.
So how are we supposed to determine the margin of error when we don't know what the standard deviation is?
Deviation. We knew what we know is we know what the high is and we know what the low is, and then there's also a formula for solving it, which is there's a formula for solving it when standard deviation is not known, which is t equals x bar minus I think it's 0 or mu. What is mu? So t bar minus, so we don't know. So yeah, how I would do it is I would just, so what you could do is you could get the t-score, and once you get the t-score, you plug it into the t-score applet, and then kind of do the algebra that way, or you can just take the margin of, or the higher percent, the maximum and the minimum, and subtract that from the mean, and then you can get your answer that way.
So did you get 2.025?
I'm actually I'm not able to get on anything Excel for some reason, so I don't know what's going on.
Are we not solving number 19? Because I'm confused now, because it says determine the margin of error.
Yes.
Yeah, that is what we're solving.
Okay. I got 2.025. Because we have the confidence intervals of 11.168 and 15.217. So what I did is I added those together, divide by 2, then you get the number between those two. Actually, wait. And then you subtract it by the top number.
So here, Seth, what you should, hold on, let me see. I didn't quite catch that. Give me just one quick second. I'm going to make sure I got the same thing as you.
Wait, wait.
So we're doing one sample t-test.
Oh, yeah, so what you can do is just do the biggest number minus the smaller number, and then you divide it by 2. I got 2.025. I just did it longer. A different way.
Let me make sure I got the same here. Give me one sec.
Hey, can I call you after my meeting, please? My math meeting. I don't know. Hey, please. Oh, I can't do this right now. What do you... I'm sorry. I'm just in the middle of the meeting. Love you. I need to talk to you on this. Bye. Or later.
So did you guys plug in that Excel sheet of that data, go into the one sample t-test? If you plug that in, you should get a confidence interval of 11.168 and 15.217.
Yeah, that's what I got. And then Seth, you said your answer. What was your answer? Your answer was 2.025?
Yes.
Okay.
Yeah, I rounded. Yeah.
Okay, because what I did is I subtracted the high of the confidence interval. I subtracted 15.217 subtracted by the mean of 13.139 or 193, and I got 2.024.
4.5.
No, mine just 2.024.
Oh, because the mean though is rounded, so you have to assume that.
I think you're right. I think if we put it either way, he would give us the correct answer, because that happened to us once where I put just 1 point off, because it could go either way. But I think it's safer to go with your route with 1 point or 2.025. So I'm gonna just put what you got, Seth.
Okay. And then for 20, I got 11.168. And 21.
1 second. One second. Sorry. I'm slower than you, Seth.
Well, it's provided. Well, I have 2 screens, so it's easier.
You have a double screen? You're lucky,
yeah.
dog.
So, well, I've used it since I had a previous job that I needed a second monitor, but now we used it as our TV for a long time, and so.
Nice, dude. Okay, so margin of 19, 2.025. Lower bound, I got the 11.168. And then the upper bound, I got the 15.217.
Yeah, that's what I got.
Cool beans.
Same.
Alrighty. Let me save all those before they go away.
All right, I'll read this one.
Okay, cool.
A random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. The data are recorded in the Excel. We want to know if there is a difference in mean listing prices between Hummers for sale in Los Angeles Group 1 and Hummers for sale in New York Group 2. Create a 95% confidence interval for the true difference of mean listing prices between the two cities. Okay.
Okay. So this one, no, it's going to be, it's going to be C, confidence intervals for the difference of means using independent samples, because we're comparing 2 things,
but they're independent.
But they're independent of each other.
So which one are we plugging this into? Are we putting it in the?
It's the 2 sample, so it's not going to be paired. It's 2 sample.
Okay, perfect.
So, and a quick way, an easy way that you can tell. Actually, hold on. All right, actually, yeah. So it's gonna be.
If it's independent, that's when you do the T-sample, right?
Yeah, it's independent. Yeah.
Okay. Perfect. I get you.
Sweet. All right. Lower bounds. Hold on, Seth. I'm gonna find this one in the textbook. I'm gonna see what you got on for the answer in the textbook.
Probably got it wrong, but I got C.
For
I'm gonna double check
for
it,
18 on 18 in this textbook, what did you get?
I think I got it wrong, but I got C.
Let me see what I got.
I'm gonna redo it.
I got C in the textbook as well, so you may be right. But yeah, let's go ahead and redo it.
I might have used the pair sample.
Okay.
All right, so yeah, it is C.
You did C? You got the same answer? Okay, so did I. So did you get -402 and then +5396?
Well, the lower bound is -423.238.
Yeah, that's what I got. My bad. I was reading D on accident. So -423, and then what was the point?
It's 0.238.
0.238, and then what was the high?
5417.336.
336. Okay, cool. Thanks for doing that.
Is that what you guys got?
So that's what I got in the textbook. That's what I got in the textbook. Where
we got the question? Sorry. I went ahead.
Right, question 23.
For 23, I got -33.669.
No, that's incorrect. Yeah, that's not even one of the answers on the textbook.
So you have to go to 2 sample t-test.
That's where I'm at.
Highlight all of the price. So make sure you're not grabbing mileage, but you're grabbing price. And you scroll all the way down from all of the Los Angeles, and you put that in A, and on B you put. And you should get -423.238.
Yeah.
Oh, you know what? I copied and pasted the wrong. I've got all the Excels up, so I grabbed the wrong one. That's why. Sorry.
I'm still grabbing all the data. My Excel's so slow.
I was like, I put in the information. Okay, so I got 2485.085.
For what?
Lower. The lower.
The lower is -4.23. Sorry, the lower is -423.
0.238.
Yeah.
What was it?
Negative.
Or you go ahead, Seth.
It's -423.238.
Yeah, that's what mine shows too.
Sweet.
So, okay, so 24.
Is 5,417.336.
Perfect. And so just to clarify, 23, it's just that full number, negative 423.238, right?
Yes.
Almost there, you guys.
Hey, sweet, Seth. Say that. So Seth, for the lower bound, you got negative 423.238. Is that right?
Correct. 0.238.
Okay, sweet. Yeah, the same.
Okay. Perfect. I just wanted to make sure that's what I got too. I just wanted to double check. So
Sweet. Okay, another spreadsheet, guys. Just get different data input.
So 25, did you get ANOVA?
I haven't. Yeah, probably because I'm using an ANOVA right now. So.
Okay.
Yeah.
That's what I got too. Pulling it up.
Yeah, before we plug it into the spreadsheet, we should know which one we're.
Yeah. Good thinking.
you cut out a little bit. What was that?
Oh,
Yeah,
yeah,
before-
good thinking. You calculate the test statistic. Okay, let's see if I get the same thing. I'm sure I do. So what question is this in the textbook? Nineteen textbook. 20 in the textbook. Seth, on 20 in the textbook, did you get C?
No.
Okay.
But now I did. For F, 7.978, yes.
Okay, cool.
Redoing it, yes.
All right, cool.
All right. So when it says calculate the test statistic, that's T, right?
No, it's going to be F.
F.
Oh, okay, I see. Okay.
And Seth, you got 7.97.
Wait, yeah, 7.978.
Okay, cool.
Yeah.
And
Then
That's
p-value, I got the 0.
0, 0.
Oh yeah, the 0.002. Because we have to round that.
too. All right, 28. Which of the following best expresses the conclusion of this test? Use a level of clearance of 0.05. Okay.
Okay. I think this is one I struggled on. So we are going to reject the null.
Hate you.
So we're rejecting the null. So I would say, so I think now that from the last test, I kind of figured it out. So I think there is insufficient evidence to conclude. I think it's B. So there's insufficient evidence to conclude that the mean of bone density of at least one of the groups is different.
Oh, so you got E on the.
I can't remember. Let me see so what question is this on a
22.
Yeah, so it's B. I had B or D. I couldn't remember. I was between those two on the test. So.
Oh. But okay, on the actual quiz though, it's B. On the homework assignment, I got E, and I think that's right.
Oh no, yeah. So I was wrong. It's not insufficient. It's sufficient.
Okay. So it's sufficient or insufficient for this quiz?
So hold on, I think it's so Seth, it's not that the groups are the same. It's going to be sufficient that the groups are different.
Okay.
So we're going with D on the test then, right?
Yes.
So
That there is
So,
sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean.
yes,
Or is
Yep,
it all
so-
of the groups are different?
I think it's at least one because we don't know. Two of them could be the same, but if one of them is different, it would. Because I think we answered a question similar on the last test, and that was what we got. So there is sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups. So D, that's what you guys got?
Yep.
Okay, so 29. This one is a dependent. Yeah, this one's dependent, so it's going to be E for 29.
Yep. Looks good to me.
Oh, so 29 is the dependent sample size?
Yeah.
Okay, so which that's C. Okay. It's
So in
C
the-
on the
on the
homework assignment.
textbook. Yeah. Uh-huh.
Okay. That's what I got, and then I didn't get the last three.
Okay. Well, this is the easy part.
Yeah, plugging it in.
So yeah. So and you're using the paired sample, or the paired t-test.
Yeah.
Thing, whatever it's called.
Oh.
For p-value, did you guys get 0.096?
Not quite there yet.
Oh, doesn't it matter which one we're comparing to?
It usually does, but I did it both ways earlier today, and I got the same answers.
Okay.
And
Are we agreed?
it does matter actually.
Or less than?
And the answers do change. But if you put 14 days first, second, you'll get answers that were one of the multiple choices in the test. If you flip them, none of the answers are there. So,
Okay.
so I got for a t-score of 1.685 and a p-value of 0.09568. So, is that not what you're getting, Seth?
No, it's not. I'm probably doing it wrong.
Test, but I didn't get. What was the p-value again? 0.0.
0.0956.
But we only do the third decimal, so it's 0.09, right? 96. I mean.
Yeah, 0.096.
That's
So
what I
you're
got.
using the 14, and you're doing that one first.
Yep, and make sure you're on paired.
Yeah.
And then also make sure that the test type is not equal to. Or do we need to change that to less than or
That
greater than?
that will only make a difference on the
P-value.
p-value. So what is our p? So I think it's. Hold on, let me go back to the problem. Good catch there.
Because I feel like it should be.
So what are we? I think she's trying to see if they're different. I don't think she's trying to see if one's less than or greater than. I think she's just.
No, because the prices go down the closer it is usually.
Well,
Or they go
usually-
up unless there's a discount, right?
Yeah, but she doesn't say that. So all the study was done. It says the study was undertaken to determine if there was a difference, not to see if one's larger or greater.
Okay.
Or larger or smaller. So it's not equal to.
Okay.
Oh,
So yeah,
Did you-
0.096 should be correct.
did you guys get a mean of 1,000?
No.
Okay, I think I have to reset it.
Yeah. Sometimes you got to just turn it off and turn it back on. Pretty much the Excel
Yeah.
spreadsheet.
Yeah, hold on for just a moment. I'm sorry.
No, you're fine.
So for number 32, would it be there is sufficient evidence to conclude that the means are different?
So it's going to be there is sufficient evidence to conclude that the, let me see here. There is sufficient, so it's going to be one of the sufficients. Mhm.
I feel like it's B.
Yeah, I think you're right. All right, so it should be done.
Yep. I'm submitting.
For the T, I got 1.68. Oh wait.
Yeah, so 1.685,
Yes.
and then for 30, and then for
5.
and then for 31, it should be 0.096.
Yes.
Mm.
0.096.
Okay.
And then
Is it
32.
9.6 or 9.56?
Well, so it's 0.096. You're going to round up to 0.09. Oh, sorry, it's 0.0956, but you're going to round up. What's that? What's that?
What's 32 again?
32 is going to be B.
There is sufficient evidence to conclude that there is difference in the mean cost of tickets purchased 14 days in advance compared to 90 days in advance.
Yeah.
Correct.
Okay.
Have you guys, has anyone submitted it yet?
Not yet.
All right, I'll go ahead and submit it, see how I do. So 96.67. What did I get wrong? Number 3 wrong.
Number 3.
So this is one that we were having some questions over.
While we're looking that far back, what was number 9? I think I missed that one.
Number 9, I got 38416.
Yeah.
I think that was the only one that I missed.
Okay. So number 3.
What did you put down for 3?
No, the top one. So no distribution of means is not normal since the sample size is not large enough. So it's going to be C. I think I'm pretty confident it's yes. The distribution of sample means is normal since the data have been determined normal. That's the answer I put on my homework.
Okay.
So
I'll check that one.
Yeah, go ahead and submit it with C, not the central limit theorem, the other one. So it should be right.
I realized I left 22 blank as well. Which one was 22?
22 was C, confidence interval for the different, for the independent samples. So.
And Thomas, you're right. Yeah. So it is
okay.
C, yes, the distribution of the mean of each sample is normal since the data have been determined to be normal.
Okay, that's what I thought. Okay, cool. All right, well, and then you got 100, Seth?
Yes, I checked.
All right, can you walk it through me real quick so I can make sure I got it? Okay.
Yep.
I'm going to retake it.
I'm ready for it if you are.
So number 1.
Hold on, wait, I'm not ready. Oh, there you go. You got me. All right.
Let me know.
All right. Okay, number 1. All right, number 2.
Number 2 is we are 90% confident. B.
Number 3.
Is C. Yes, the distribution of the mean of each sample is normal since the data have been determined to be normal.
Okay.
Number 4 is C. Confidence interval for the difference of means using independent samples.
Okay.
5 is D. Obtain the balance of 90 bank customers rather than 30.
Okay.
Number 6 is 1.96.
Okay.
Number 7 is 998.04.
All right. Then it's 1001.96, right?
Yes, for 8, 1001.96. Number 9 is 38416.
38416.
Yeah, 38416.
And that was number 9.
Yes.
Okay. Number 10.
Number 10 is D. Null equals 1250, and then HA is
Alligator's eating the number, right?
is eating 1250. Yes. Mu is
Okay,
eating.
cool.
Yeah.
Okay. All right. 11.
Is the p-value is less than alpha? B.
Okay.
Number 12 is C. Yes, it is enough that the data for each apartment building are bell-shaped with no outliers, and the sample variance are nearly equal.
Cool.
Number
Okay.
13 is A. Committed a type 1 error. 14 equals A. By reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
Sweet.
15 is D. Reject null, H-O. Question 16 is independent sample t-test, which is B.
Okay.
17 is D. Dependent samples. If you select a brother so as to compare his academic achievement to his sister, you must include the sister in your study. So it's D.
D. Okay.
18 is A. Confidence interval for mu when standard deviation is unknown.
Okay.
19 is 2.025.
Okay.
Question 20 is 11.168.
Okay.
Number 21 is 15.217.
Okay.
Question 22 is C. Confidence interval for the difference of means using independent samples.
Okay.
Okay, 23 is negative 423.238.
Okay.
24 is 5417.336.
5417.336.
Yes, 5417.336.
Okay.
Then 25 is ANOVA.
Okay.
26 is 7.978.
Okay.
27 is 0.002.
Okay.
28 is C. There is sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups.
Sweet.
Or that's D. That's D. I'm sorry.
Okay. So can
There's-
you read it one more time?
So it's D. There is sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups.
Okay.
That one has A through
And,
E.
and
I'm
it's,
sorry.
so an edge D, so second from the bottom.
Yes, correct.
Okay. Alrighty. 29 is
Dependent sample test.
so that's E.
Yes.
What was the test statistic for 30?
1.685.
1.685. All right, and it was 0.09 or something like that.
Yeah, for 31, it's 0.096.
Okay.
And then 32 is B. There is sufficient evidence to conclude that there is a difference in the mean cost of tickets purchased 14 days in advance compared to 90 days in advance.
And that was B, right?
B, yes.
Okay, let's see here. The only way I get something wrong is if I just had a typo. Okay. All right, sweet. Good job, guys.
Cool, 100?
Yep, we got it. We're all squared away.
All right, good.
All righty. Well, we'll see you guys next week. Good luck on your tests.
All right, same.
Yeah.
Take care.
Love it.
Yeah, nice to meet you, Garrett.
Yeah, glad to be here.
All right, later, man.
All right, see ya.